Welcome to the College Algebra Trig Semester 1 Final Exam Review. I know my writing on here isn't the best. Hopefully I'll get better as I learn to write on the iPad nicer. So here we go. Find the zeros of h of x equals x squared plus 5x plus 2. Zeros are also known as roots or solutions, and what they are ultimately are x-intercepts, where your graph crosses the x-axis, which means they don't move any up or down, they only move left or right. So your y value, or h of x, which I did not mean to just erase, h of x is going to have to be 0. So I get 0 equals x squared plus 5x plus 2. My first instinct is to factor this because your a value is 1, which makes it nice and easy. But your only factors of 2 are 2 and 1, which do not add up to 5. So another method we have for solving quadratics is using the quadratic formula, which I'm going to put right here for us to look at. Okay, so I'm going to plug in my values. Opposite of b, so negative 5 plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And when I do the math underneath the square root, I end up getting, let's see, 5 squared is 25, minus 8 will give me the square root of 17. This cannot be simplified, so that problem is done. Number 2, solve the square root of 8x minus 15 equals x. So I do not like square roots in my problems. I want to get rid of them. So I'm going to square each side. On the left-hand side, the square root and the square cancel out. So I'm simply left with 8x minus 15 equals x squared. And again, we're left with a quadratic equation. Okay? How do I know? Because it's raised to the second power. So, hold on one second here. I just want to erase this. It's a little hard to... I want you guys to think that's a 12. Let me go in and erase that whole thing there. And that will help us out. Okay. So, it's a quadratic. And again, we have two methods of solving quadratics. You can factor or you can use the quadratic formula, but not until it equals 0. So, the first thing I have to do is subtract 8x and add 15 to each side. 8x minus 8x is 0. Negative 15 plus 15 is 0. So 0 equals x squared minus 8x plus 15. You could use the quadratic formula, but when a is 1, I tend to look at factoring. Okay, factors of 15 are 1 and 15, or 3 and 5. I have to figure out the signs on these. Here's how I do my signs. I look at the sign on b. It goes with the bigger number. Okay, so we're going to make negative 15 and negative 5. Then I look here when I multiply them, is it supposed to be positive or negative? In our case, it's supposed to be positive, so you have to ask yourself, a negative times what sign will give me a positive? That means the others have to be negative. The only ones that add up and give me negative 8 are going to be negative 3 and negative 5. Okay, so I'm going to rewrite this as 0 equals x minus 3 times x minus 5. I have two factors being multiplied equaling 0. That allows me to set each one equal to 0. So when I do x minus 3 equals 0, I find x is 3 by adding 3 to each side. And when I let x minus 5 equal 0, I add 5 to each side to find out that x is 5. And again, if you wanted to go back and use the quadratic formula instead, you would get the same answers. Question 3 says solve the absolute value of 2x plus 5 equals 16. When you do absolute value problems, you have to be careful. A lot of people will rewrite it without the absolute value sign and solve it. And they're halfway right, because the absolute value of 16 indeed is 16. But what they're forgetting is the absolute value of negative 16 is also 16. So what's inside the absolute value signs can equal positive or negative 16. So we're going to go through and solve these. If I subtract 5 from each side and then divide by 2, there's one answer. And the same process on the other side. If I go in and subtract 5 and then divide by 2, I get 11/2 and negative 21 over 2. Okay, we are going to move on to number 4, which says evaluate the function f of negative 2 for f of x equals 4x squared minus the square root of negative 6x. So this is function notation, and what this is telling you is what's inside the parentheses next to your function is going to replace every x value in your equation. So my x's are going to become negative 2. Please be careful. The biggest mistake I see here is somebody writes this. Do not write this. Okay? 4 times negative 2 squared. The issue is if you plug that in your calculator wrong, without these parentheses, it will give you the wrong answer. So my rule of thumb is anytime I plug in a negative number, I put it in parentheses. So again, all I did was replace every x up here, and I'm going to go ahead and highlight those in red for you, okay? Every x up there, all I did was replace them with a negative 2 down here. When I do this math, I find out that f of negative 2 equals, well, negative 2 squared is 4. 4 times 4 is 16 minus. Negative 6 times negative 2 is a positive 12. Okay, I cannot leave it like that because the square root of 12 can be broken down. 2 times 6. Remember, once it can't be broken down anymore, to make sure you circle it. Since it's a square root, I need groups of 2 to come out. So it's going to become 16 minus, let's see, I have a group of 2's, but they don't both come out. Remember, one disappears and one comes out. And then whatever's left, which is the 3, stays underneath the square root sign. Okay, moving on to number 5. Number 5 says if f of x equals x squared when x is less than or equal to negative 1, or square root of x plus 3 when x is greater than negative 1, find f of negative 7. This is very similar to number 4, except they give us 2 equations. Do I use them both? Do I use one? How do I know? Here's how you know. You have to look at the restrictions on x. So look at these equations or these inequalities on the back end and figure out where negative 7 belongs. So if I look at the top, is it true that negative 7 is less than or equal to negative 1? Or is it true in the bottom that negative 7 is greater than negative 1? That is definitely not true. Negative 7 is not greater than negative 1, so I'm not using the bottom equation. Instead, I'm just going to plug it in up top. So f of negative 7, again, be careful raising a negative base to an exponent. It must go in parentheses. Negative 7 squared is 49. Okay, we are going to talk about the domain of functions for number 6. I want to start by reminding you domain is asking what x values can be plugged into your equation where you get out real answers. Okay? There's only 2 times it doesn't happen. You're going to have issues when you have a square root. Anything underneath the square root has to be greater than or equal to 0. Or when you have a fraction, the bottom cannot equal 0. If you don't have either of those, then your domain is negative infinity to positive infinity. But I do have that. Down here, I have a fraction. So I know that x times x squared minus 49 cannot equal 0. When I have 2 things being multiplied together equaling 0, or in our case not equaling 0, I can just take them and separate them and say they both can't equal 0. So this one is already solved. This one I'm going to add 49 to each side, and then I'm going to take the square root of each side. Don't forget, when you take the square root of a variable squared, your answer is both positive and, but I still have to write it in domain notation. which means I'm still starting at negative infinity, but I have to think about what number am I going to come across first if I'm traveling from the left. The first x value that I cannot be is negative 7. And then I continue from negative 7. What's the next number I'll hit? 0. Then I continue from 0. What's the next number I'd hit that I cannot be? 7. Then I continue, and there's no more numbers that I can't be. So I go from 7 all the way out to positive infinity. I know that's a little sloppy down there.